Hello everyone and welcome back to exercise number 45 of SolidWorks basic tutorial series. In this video, we're going to be designing a Flanged Tee Body. As always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extruded boss base feature and extrude cut feature, but also in creating the main body of the component, in particular this conical circular body. We're going to be using the revolve boss base tool. Here we see the schematic drawing for exercise number 45. All dimensions are in millimeters. If we zoom closely here, we see that the unit system is set to millimeter, gram, and second. We have the isometric view, the section view, and the section view showcases what we see on the inside of the component. We have the top view, the section view, and the side view. And this section view was taken along this vertical line. We see here that we have a number of pink vertical lines, and these are lines of symmetry, right? So we can see here clearly that the component has line of symmetry. If we look at the top view along this vertical line, the same is the case with regards to the section view and the right view. And of course, as always, we had a question here that reads, what is the mass of this part in grams? And in answering this question, we need to apply a material of ASI 1020 steel. And we have two notes here at the bottom. One of the notes says, unless stated otherwise, all fillets have a radius of 5 millimeters. And if we have any chamfers, and we do have a number of chamfers, the chamfers have a dimension of 2 millimeters and an angle of 45 degrees. All right, so looking at the main features of the component, we see that we have two flanges here on either side of the component. In addition, we have a number of mounting holes for the two sides of the flange, and we have a top flange, a top square flange with 4 mounting holes as well. And we have an opening here that runs along the vertical line here of the component, starting from the top flange, the top square flange, all the way to the inner opening of the body. Okay, so how are we going to model this within SolidWorks? And the key here, if we look closely, is to use the section view. And the strategy here is that we're going to sketch out 1/4 of the component using the line tool, and then we're going to use the offset entities tool to create the thickness of the component. After that, we're going to use the revolve boss base tool to create the main body of the component, this main circular or spherical, or how do I say it? The main conical section of the component. Okay. After that, we're going to work on creating the mounting holes for the two sides of the flange here. So we're going to sketch out a number of holes and then use the extrude cut tool to create the opening. And in creating the top flange, the square flange here, we're going to have to create a new drawing plane that is 132 millimeters away from the center line here. So after that, we're going to use the sketch tool and sketch out the square flange, and then use the extrude boss base tool to create thickness for the top flange, as well as the cylindrical body for the top flange as well. So it's a pretty straightforward process, and the component is relatively easy to model within SolidWorks. Okay, so with that aside, let's get started with exercise number 45. Okay, so let's start by creating a new SolidWorks part. Let's set the background to plain white, and let's copy exercise number 45 into SolidWorks. Let's go ahead and reposition this and make it smaller. Okay, so as I said previously, the strategy here is to begin by sketching out 1/4 of the section view that we have shown here, utilizing, of course, the line of symmetry shown in pink that runs along the vertical axis here, the y-axis. So to start, let's go ahead and select the front plane, sketch. And what we're going to do is activate the line tool. And starting from the origin, we're going to sketch out the basic profile of 1/4 of the section view here. All right. And let's go ahead and close off the sketch. Okay. Looking at the section view, we see that the overall length of the component from one end to the other is 328 millimeters. So activate the Smart Dimension tool, and the length of this edge here at the bottom should be 328 divided by 2. So again, since we're sketching only one half of the entire length, and press enter. All right, and if you look closely here, we see that the flange has an overall diameter of 200 millimeters, and since this part right here corresponds to half of the flange, the length of this edge should be 100 millimeters, right? The thickness of the flange is 22 millimeters, and this is, of course, according to the image here. We see that the thickness of the flange on either ends should be 22 millimeters. All right. Now, if we look closely here, we see that the angle between this slanted line with respect to the center of the component should be 5 degrees. All right, so this here, the angle between this edge and this horizontal edge should be 5 degrees. All right, let's drag this all the way to the inside of the sketch here. Okay, and if we look closely here at the section view, we see that if we extend this edge here, this slanted edge, all the way to the right line here at the side, we see that the overall diameter of the length here should be 105 millimeters. So what we're going to do is very simply, select Extend Entities, and we're going to extend this line all the way to this horizontal line here, the vertical line right here. Activate the Smart Dimension tool and set the distance between this point and this point as 105 divided by 2. All right. And what we're going to do again, extend entities, we're going to extend this all the way to the bottom right here. Activate the Trim Entities tool. And what we're going to do is very simply, we're going to delete any extra entities that we have, and then use the Offset Entities tool and set the offset distance as 15 millimeters. All right, so if we look closely here, we see that the sketch here is fully defined. All entities or all lines are in black. So what we're going to do is just very simply delete this line. Okay, again, now the sketch is underdefined, but since we've already defined the dimension, we know for certain that it's fully defined. Anyway, so select Offset Entities, and we're going to select this line and set the offset distance as 15 millimeters. All right. Control Z, Offset Entities, 15, and then select OK. Again, select Extend Entities, and we're going to extend this line all the way to this vertical line right here. Select Trim Entities, and then go ahead and delete any extra entities that we don't need. All right, delete this line. Let's convert this line to a construction geometry by pressing Q. All right. And that leaves behind the 2D sketch for the section view right here. Okay, so now we're going to press S on your keyboard and select Revolve Plus Base. Here it's going to ask us for the axis of revolution, and go ahead and select this construction geometry here, and then select OK. And that creates 1/2 of the T-body flange here. So now we're going to select the Mirror Entities tool. Here it's going to ask us for the face or plane you want to mirror along. Select this face and then select OK. Okay, so now what we need to do is we need to work on creating these mounting holes, these holes here on either ends of the flange. So to start, let's go ahead and select this face, sketch, activate the circle tool, and from the origin, we're going to draw a circle. Now this circle here will serve the purpose as a pitch circle. And this circle will help us determine the position of the mounting holes relative, of course, to the center point of the origin or the origin of the component. So now just press Q on your keyboard to convert this to a construction geometry. And if we look closely here at the schematic drawing, you see that we have a pitch circle with a diameter of 160 millimeters. So this needs to be 160 millimeters. All right, activate the circle tool again, and we're going to sketch out one profile, one circle for the mounting hole right here, starting from this point here. Activate the Smart Dimension tool. And if we look closely, we have 12 holes, 6 on either side or either side of the flange, 12 in total. And the diameter of each hole should be 18 millimeters. All right, so this needs to be 18 millimeters. Select circular sketch pattern. And for the entities of pattern, go ahead and select this circle. Set the number of copies as 6. And then select OK. Press the S key, extrude cut, and right-click on your mouse and set the end condition as through both directions. And that will extend the 2D cutting surface all the way to the other side of the flange here. And then select OK. All right, so that creates the 12 mounting holes on either side of the flange here. Okay, so if we look closely here, we see that we have a fillet edge that we need to create for the inner intersection line here and the outer intersection line, and the fillet radius needs to be 20 millimeters. So go ahead and select fillet, set the fillet radius as 20 millimeters, select this outer edge and this inner edge as well, and then select OK. All right, so now select fillet entities again. If we look closely at the section view, we see that we have a fillet radius of 5 millimeters. So select 5 millimeters. And then select this outer edge, in addition to the outer edge on the other side as well. Okay. So now if we look closely, let's put this to the side here. If we look closely here, we see that we have a square flange at the top with an opening that runs along the component. So what we need to do is actually create a new drawing plane that is approximately or exactly 132 millimeters away from the center line here, from this origin point here. So go to reference geometry, select plane. We're going to create a new drawing plane relative to the top plane right here. All right. And we're going to set the offset distance as 132 millimeters and then select OK. Right-click on this new drawing plane, sketch, activate the center rectangle tool, and starting from the origin here, we're going to draw a rectangle. All right. Set the relation between these two entities as equal to convert it to a square. Activate the Smart Dimension tool, and this needs to be 150 millimeters. Okay, so now press S on your keyboard, extrude boss base. We need to extrude this 2D sketch to a thickness of 22 millimeters. All right, so what we need to do is reverse the direction, extrude in the downward direction, and set the distance extrusion thickness as 22 millimeters. All right, let's go ahead and hide this drawing plane. Let's select this bottom face, sketch, activate the circle tool, and from the origin here, draw a circle. All right, activate the Smart Dimension tool, and if we look closely at the section view, we see that this pipe here, this pipe section, should have a narrow diameter of 18 millimeters. So this needs to be 18 millimeters. All right. Press S on your keyboard, extrude boss base, set the end condition as up to next, so right-clicking mouse, and then select up to next. All right, and then select OK. Now, you need to remember here that we have the edges here for the top flange are rounded out, right? So there's a fillet here. So if we look closely, we don't have a dimension that directly telling us what the fillet radius should be, but we can deduce it. We can derive the fillet radius if we take this dimension here, 150 minus 110, which gives us 40 millimeters, divided by 2. So the fillet radius needs to be 20 millimeters. So go ahead and select fillet, assign a fillet radius of 20 millimeters, and then go ahead and select these 4 edges, 1, 2, 3, and 4. All right. Okay, so now what we need to do is create an opening, a hole basically, running along the center of the component, and the hole should have a diameter of 55 millimeters. So go ahead and select this top face, sketch, activate the circle tool, and from the origin, draw a circle, activate the Smart Dimension tool, Set the diameter here as 55 millimeters. Press S on your keyboard, extrude cut. Right click on your mouse and set the end condition as up to next. Okay, so this will cut this, create a hole here that goes all the way to the inner surface of the component right here. Now we need to enlarge this hole, so go ahead and select this top face, sketch, and if we look closely here, we have a second hole, a second circle that we need to create, and the diameter of this circle should be 80 millimeters. So go ahead and draw a circle starting from the origin, activate the Smart Dimension tool. This should be 80 millimeters. Press the S key, extrude cut. And we need to set the end condition as blind and set the extrusion cut depth as 8 millimeters. All right, so now we need to create the mounting holes for these for this top flange. So what we need to do is select this top face, sketch, activate the circle tool, and automatically if we hover over this curved edge here, we have the center of a circle. So draw one circle, a second circle right here. That's 2, 3, and 4. Select these 4 circles. And set the relation as equal. All right. Activate the Smart Dimension tool. And set the dimension as 18 millimeters. All right, press the S key, extrude cut, set the end condition as up to next, and then select OK. And that creates the 4 mounting holes for this top flange. All right, so now what's left is actually look closely here, we see that we have a fillet radius between this cylindrical body and the main body of the component here. So let's go ahead and select fillet, and we don't actually have a dimension here for this fillet, but we do have a note that says that unless stated otherwise, all fillets have a radius of 5 millimeters. All right, so let's go ahead and set the fillet radius as 5 millimeters, and let's go ahead and select this edge and then select OK. Finally, we have a number of chamfers that we need to create. So again, if we look at the note here, so that all chamfers have a dimension of 2 millimeters with an angle of 45 degrees. So let's go ahead and assign this as 2 millimeters. It's already set 2 millimeters. Now let's go ahead and select certain edges. You have this edge, not this face, sorry. This outer edge right here. Yeah, this edge as well. You have this edge. So I'm basically selecting certain edges that need to be chamfered. All right, and then select OK. Okay, so that completes the modeling process, and now we've determined the mass of the part, so we need to assign a material. So right-click here, Edit Material. Select ASI 1020, Apply, and Close. Select this image. Let's go ahead and delete this image. Now for the moment of truth, go to the Evaluate tab, select Mass Properties, and if we look closely here, we have a mass of 23,894 grams. 23,894 grams. That is our final answer. Okay, so that concludes exercise number 45. If you have any comments or questions, please leave them down in the comment section below. Also, don't forget to like and subscribe. I'll see you all in exercise number 46 until we meet again. Bye-bye.